Hey everyone, today I'll show you the graph of four important trigonometric functions: the tangent, cotangent, cosecant, and secant. I'll explain their differences, where they came from, and the step-by-step process to graph them. First, let's begin with tangent function. Y is equal to tangent x. The tangent function is actually the ratio of sine to cosine. Tangent x is equal to sine x over cosine x. Since division by 0 is undefined, the graph of y tangent x will have vertical asymptote, whereas cosine x is equal to 0. This happens at x is equal to pi over 2, 3 pi over 2, 5 pi over 2, and so on. To graph the y tangent x, first you have to identify the period. The period of a tangent is pi. This means the pattern repeats every pi units. Second, mark vertical asymptotes. This occurs at x is equal to plus minus pi over 2 plus minus 3 pi over 2 and so on. Next is you have to plot the key points. Use 0 and 0, pi over 4 and 1, negative pi over 4 and negative 1. Then lastly, you have to draw the curves. The graph moves upward on the right and downward on the left between the asymptotes.
For our example number 1, we have y is equal to tangent x minus pi over 3. We have to get the period first, which is pi over b. We don't have the b, so we only have pi. Next is the phase shift, c over b. We have our c, pi over 3. And we don't have the b, 0, so it is equal to pi over 3. 2. And now let's get the two asymptote. Start with negative pi over 2 to pi over 2. So negative pi over 2 less than bx minus c less than pi over 2. So we have to interchange the middle, which will become x minus pi over 3, then copy the outer. So to get rid of the middle, we have to add the same thing but different sign. But also when we add something inside, we have to add also the both sides. So now we can get rid of this and become x. So negative pi over 2 plus pi over 3 is equal to negative pi over 6. Then pi over 2 plus pi over 3 is equal to pi over 6. And now we have to add this 2, then divided by middle. To get 2 pi over 3 divided by 2 is equal to pi over 3 in 0. And now let's do the table of values. In order for us to not get lost when we do the graphing later, our table of values composed of x and y. Since we're just graphing one period, we only have 5 points. And now let's put the first asymptote, which is negative pi over 6. And our last asymptote is 5 pi over 6. And our middle is pi over 3. Then negative pi over 6 is undefined. Also pi over 6 is undefined. And 0. Then we have to add this 2, then divided by 2. So we get the pi over 12. And since tangent 1, so negative 1. And we have to add this 2 and divide as well. Then 7 pi over 12 and positive 1. And now let's do the graphing. We have to put all our x here. We just start with negative pi over 6, pi over 12, pi over 3, 7 pi over 12, and 5 pi over 6. Then we have this 1, 2, 3, negative 1, negative 2, and negative 3. Now let's do the plotting. First is we have to add the broken lines for our first asymptote, negative pi over 6. We also do this to our second asymptote later. And now for our second asymptote, in 5 pi over 6, we'll do the broken line as well. And now let's do the plotting. Our pi over 3 is paired with 0. And our 7 pi over 12 is paired with positive 1. And lastly, our pi over 12 is paired with negative 1. Then next we do the drawing of curves. So we carefully do the curve. It should be closer enough to the asymptote but not enough to touch those. Last is we have to write the range and domain.
For our range starts from negative infinity to positive infinity. And for our domain, the domain is all real numbers except values where x is equal to pi over 3 plus pi over 2k, where k is any integer. See the example number 2. Y is equal to tangent 1/4 x minus 3. For our period, we have pi over b is equal to pi over 1/4 and equals to 4 pi. Then next is the phase shift, our c over b. We don't have c, so 0, and our b is 1/4, so it is equal to 0. Of course, to get the two asymptote, we have this negative pi over 2 less than px minus c less than pi over 2. And to get this, you have to interchange the middle, which is the 1/4 x. Then copy the outer pi over 2 and negative pi over 2. To get rid of the middle first, copy the negative pi over 2, copy the 1/4 x less than pi over 2. Then you have to divide all sides with 1/4. So 1/4 and 1/4. Then now we have negative 2 pi less than x less than 2 pi. To get the middle, we have to add this 2 and divide it by 2, so we have 0 and negative 3. And now let's do the table of values. By doing this, it helps us later when we do the graphing in order for us not to get lost. We have here our x and y since it is 2 periods, so we have at least 10. And now let's put all our first asymptote in the first and the fifth. So we have negative 2 pi, then 2 pi in the fifth column, then in our middle is 0. Since negative 2 pi is undefined, you have to put it undefined, 2 pi as well undefined, and for our 0 it is negative 3. To get this, you have to add this 2 again, then divided by 2 is equal to negative pi, then same is equal to since negative 5. Then we have to add this 2 again, and then this is to pi, then negative 1. Same process you have to, and so we get the 8 pi, then we also add and divide by 2, so we get the 5 pi, then and it is equal to negative 1, then it is equal to negative 3, and for the 6 pi, then
they add is equal to 7 pi. That is our negative 5 and undefined. Since we already have our table of values, we'll not get lost later. So we do the graphing now. Let's put all our x here from negative 2 pi to positive 6 pi. Since we already have the table of values earlier, we can follow it. And now let's write the negative 1, negative 2, negative 3, negative 4, negative 5, then 1, 2, 3, and so on. So here we have to mark our first asymptote, second, and also the third one in order for us to have a guide. So let's mark the negative 2 pi since it is our undefined and our first asymptote. Then let's do it as well for our second asymptote, which located into pi. Then for our last asymptote, we have to do it as well in 6 pi. And so since it is y tangent 1/4 x is negative 3, we have to go down in negative 3. It will be our origin. So now we have to line it using the broken line. And now let's mark for graphing. We have 0 to negative 3. When we also have negative pi to negative 5 to mark it. And also in our pi, we have the pi and negative 1. It already shown in our table of values, you have to follow it, where this 3 pi is paired with negative pi, then our 4 pi is paired with negative 3, and lastly, our 5 pi is paired with negative 1. We're already done in plotting, so our next step is we have to graph now. But in graphing, we have to be careful so that it don't implies something, and it must be closer to asymptote but not enough to touch. Now let's do the perfect curve, We do this in our first, we also do this in our next. Carefully graph it. What we do in our first must be done in our second. We have to curve it perfectly as well. Since we're almost done in our graphing, and now let's do the identifying the domain and range. First, our domain is all real numbers except values, whereas x is equal to 2 pi plus 4k pi, where k is any integer. For our range, we have from negative infinity to positive infinity.
And now let's graph the cotangent function. Now let's look at cotangent y equals to cotangent x. Cotangent is reciprocal of tangent. Cotangent x is equal to cosine x over sine x. Since division by 0 is undefined, the graph of y cotangent x will have the vertical asymptote, whereas sine x is equal to 0. This happens at x is equal to 0, pi, 2 pi, and so on. So the step-by-step process in graphing the cotangent, first you have to identify the period. Cotangent has a period of pi just like tangent. Second, mark the vertical asymptote. This occurs at x is equal to 0, plus minus pi, plus minus 2 pi, and so on. Third, you have to plot the k points, use pi over 4 and 1, 3 pi over 4 and negative 1. Then lastly, you have to draw the curves. Unlike tangent, cotangent decreases from left to right.
So we have here the y is equal to cotangent x plus pi over 6. Same with tangent, we get the period first. Period is pi over b, so we have pi, we don't have b, 0 is equal to pi. Then phase shift, we have c over b, so c pi over 6. When our b is 0, so we have, since it's positive, it becomes negative pi over 6. And to get the two asymptote, we have, in cotangent, we have 0 to pi. So 0 less than bx minus c less than pi. So you have to copy the 0, and the middle change is x plus pi over 6, then pi. Then change out with negative pi over 6. What we do in the middle should be done in the outer as well. So added with negative pi over 6. You can now get rid of the middle. It becomes x, then it's also negative pi over 6, and now we get the pi over 6. Now let's add this 2, then divide it by 2, and 2 pi over 3 divided by 2 is equal to pi over 3 and 0. And now let's do the table of values again in order for us to not get lost when we do the graphing. And since it's one period, we only have 5 points. We have to put first the negative pi over 6 and pi over 6, and our middle is pi over 3. Negative pi over 6 is undefined, and pi over 6 is undefined as well, and our pi over 3 is 0. Then we have to add this 2, then divide by 2, it causes pi over 12. And we have this positive 1, added 2 and divided by 2, we have the 7 pi over 12, then negative 1.
Since we are done doing our table of values, now we have to do our graphing. We have to put all our x from negative pi over 6, pi over 12, pi over 3, 7 pi over 12, consider 5 pi over 6, and now I have negative 1, negative 2, negative 3, 2, 1, 2, and 3. Since it's one period only, we have to mark our two asymptotes from negative pi over 6, and also we have to do this in 5 pi over 6 as well. For our next asymptote, we have pi over 6. We have to mark it as well with our broken lines. And now we are done in marking our asymptote. We have to mark or plot our rest, which is 0 and pi over 3, then positive 1, 2 pi over 12, and 7 pi over 12 is equal to negative 1. Now we have done plotting. We're going to graph now. You have to carefully do the curve, and we must touch this asymptote but not closer enough to touch it. Do our perfect curve as well in up. It is a one period, so we have only one graph. Now we have our perfect curve. And now let's do the range and domains of our range. We have negative infinity to positive infinity, and for our domain, we have the domain is all real number except k pi minus pi over 6. And now let's proceed for our example number 4. We have
Pi is equal to 1/3 cotangent 2x plus 3 pi halves plus 1s. So first we get the period. In order to get the period, it's up to pi over b. Our b is 2. So we have this pi over 2. Then next is you have to get the phase shift. For phase shift is c over b. Our c is 3 pi halves and our b is 2. So we get 3 pi over 4. And now we have to get the two asymptote. To get the two asymptote, we have 0 to pi. So 0 less than bx minus c less than pi. So we have to change our inner, which is the 2x plus 3 pi halves. Then we have to copy the outer, which is the pi and the 0. Our first goal was to remain the x only in the middle. By doing so, we have to add 3 pi halves but in different sign. But also, doing this, we have to add the both side as well, what we add in the inner. So now we can cancel this out and it would remain 2x. So 0 minus 3 pi halves is equal to negative 3 pi half. So pi minus 3 pi halves is equal to negative pi halves. To cancel this out, we have to divide it by 2 and divide it by 2 the both side as well. So we get negative 3 pi over 4 and it will remove, so 6, and we have negative pi over 4. To get the middle, we have to add this 2 and divide it by 2, so we get negative pi half, and which is we have 1 here, so 1. And now let's do the table of values in order for us to not get lost when we do the graphing later. Since it's 2 periods, so we have less than column here. It is for our x and y. And now let's put our negative 3 pi over 4, since it is our first and our fifth asymptote. Our second asymptote is negative pi over 4, and to our middle, which is a negative pi over 2. Negative 3 pi over 4 is undefined since it's our first asymptote. Is negative pi and 2 is 1, and negative pi fourth is undefined as well since it is our second asymptote. We have to add this 2 and divide it by 2 to get the negative pi over 8, and our a is 1/3, so we have to put the 1/3 here. Then we have to add this 2 again and divide it by 2, so we get negative 3 pi over 8, and we have to add this 2, so we get the 2 over 3. Now to get this, by observing this first period we already know what is the distance between. So the distance is pi over 8. We have to add pi over 8 again, but we have to get our last asymptote, which is pi over 4. Then it is undefined since it's our last asymptote. For middle, we have 0 and 1. Then now we have to add this 2 and divide it by 2 to get negative pi over 8, and it is 1/3. Then we have to add this 2 again and divide it by 2, so we get pi over 8, then 2/3. Since we're already done doing our table of values, so let's now move to graphing. We have to put all our table of values here. So first step is we have to mark our all asymptote. So we already know that our identifier asymptote, which should be located in negative 3 pi over 4, the negative pi over 4, and the pi over 4. So we have to mark first in negative 3 pi over 4 for us to know the boundaries of our graph later. We have to listen patiently to it. Our last asymptote is pi over 4 as well. If you want to try to graph on your own, you can pause the video and try to graph it. Just follow the table of values for you to not get lost, and it's way more easier for you to locate each graph or to plot it. For our last asymptote or the middle asymptote is located in negative pi over 4. We have to mark this as well. This asymptote stands as our boundaries to our graph later, since it's 2 period. Now we have to mark this. It will stands as our origin, since we have +1 here. So move upward from 0 to 1. So we have to carefully do it. It must straight line, straight broken line, so that our graph will look formal and presentable. And now let's do the plotting first. We do the plotting so that our graph will be perfect or look perfect. So our negative pi over 2 is in 1 based on our table of values earlier. And our negative 3 pi over 8 is in 1/3. So we have to plot it 1/3. Then our negative 5 pi over 8 is in 2/3. First, have this 0 and 1. We have to plot it as well. And for pi over 8 is in 1/3. And lastly, our negative pi over 8 is in 2/3. So we're already done pointing it out. So we do now is to do the perfect curve. To slowly do it. Our main goal here is to make this curve closer to our asymptote, but not enough to touch them. So you have to carefully do our perfect curves. Do it with slowly but surely. So what we do in our first period, we also do this in our next or our second period. Carefully do this here as well. Slowly. But surely. Since we are done drawing our perfect curves, we are now moving to our last part, which is identifying the range and the domain. So our range is from negative infinity to positive infinity. And for our domain, we have all real numbers except k pi over 2 minus 3 pi over 4 k which is k, is element of any integers.
Let's move on to graphing cosecant function. Y is equal to cosecant x. Cosecant is the reciprocal of sine. Cosecant x is equal to 1 over sine x. Since division by 0 is undefined, the graph of y cosecant x will have vertical asymptote wherever sine x is equal to 0. This happens at x is equal to 0, pi, and 2 pi, and so on. Here's the step-by-step process in graphing cosecant. First, you have to graph the sine x lightly as a guide. Second, you have to mark the vertical asymptote. This occurs at x is equal to 0, plus minus pi, plus minus 2 pi, and so on. Third, you have to identify the key points. At sine's maximum, cosine has a minimum of at y is equal to 1. At sine's minimum, cosecant has a maximum at y is equal to -1. And lastly, you have to sketch the U-shaped branches above and below the sine curves.
So let's move to the example number 5, example of cosecant. So y is equal to cosecant x plus pi over 4 minus 1. So the reciprocal of cosine is sine, so it becomes 2 sine x plus pi over 4 minus 1. So doing so, we have to get our amplitude first. Our amplitude is, as you can see, it's 2. For our period, which is the 2 pi over b. So our 2 pi is equal to 0 since we don't have b, so 2 pi. Our phase shift is c over b. Our c is pi over 4, and our b is 0, so we have pi over 4. And for our distance, each k point is period over 4. Our period is 2 pi over 4. Okay, it is pi over 2. Now let's mark this. Then let's do the table of values. In order for us to not get lost, we need to do the graphing as always. It should have y and x, so it's 2 periods, so 10. You can pause the video and do it for your own and check later if you're doing great. Now let's write the first, which is our negative pi over 4. Negative pi over 4 plus pi over 2 is equals to pi over 4. Then same process, you have to add the distance each k point, which is the pi over 2. So it becomes 3 pi over 4. And you have to add the pi over 2 again. And this pi over 4. Then same again, we have to add pi over 2, so 7 pi over 4. And it comes to 9 pi over 4. Then add again pi over 2, which is your distance, 11 pi over 4. And now we have to add again, it becomes 13 pi over 4. And lastly, you have to add, for the last time, we became 15 pi over 4. And now, since we're already done for our x, we're going to move for our y, which is we have this -1, since we start with. So from origin is -3. Since it's 2, becomes -1. Start with -1, so our new origin. And it comes to 1 again. And then -1. So -3. Then -1. Then 1. -1. -3. Since we are done doing our table of values, we can now do or move to our graphing. We have to put all our x here, so from negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4, 13 pi over 4, and lastly our 15 pi over 4. You have to put our -1 for our y, -2, -3, -4, -5, then 1, 2, 3, and now since it has -1, or we have to move downward, so it becomes our new region in our -1. So we're gonna start here instead of the 0, so do the broken lines as our sign here to start here instead of the 0. And now let's do our plotting. So for our -pi over 4 is with -3. So our pi over 4 is in -1. Our 3 pi over 4 is in 1, and our 5 pi over 4 is in -1, and our 7 pi over 4 is in -3, as you can see in our table of values earlier. You have to just follow it. It will make your life easier. So 9 pi over 4 is in -1, and our 11 pi over 4 is in +1, and our lastly our 3 oh no, not last our 13 pi over 4 is in -1, and lastly our 15 pi over 4 is in -3. So since you're done plotting, we can now do the graph. You have to graph it with a broken lines. So sorry if my graph is not that perfect. As you can see there. Not that. Carefully do it. You have to carefully do it so that you can make a straight graph or a perfect graph or perfect sine graph, since it is our first step in doing a second graph. So I'll say sorry for not. My graph is not that perfect, especially in this first side. Later, you can do graphing on your own for you to know as well. So remember, you have to do your graph perfectly so we'll get another meaning. And now let's do the broken lines for our asymptote. Every in -1, it will stand as our asymptote. Then let's do it. Or it is fine. Since pi over 4 is in -1, so ito yung first asymptote, and 5 pi over 4 is in -1 as well. It is our second asymptote. And for our 9, pi over 4 is in -1 as well, so it is our third asymptote. And lastly, our 13 pi and 4 is in -1 as well. It is will become our last asymptote. And now let's do the U-shaped branches, and every highest and the lowest peak of our point or our graph. So we do the form of U. We have to graph it perfectly to form our U shape. It must be closer to our asymptote but not enough to touch them. So we have to carefully do it in up as well. So this is now our cosecant graph. Since we are done our graphing, now let's move to writing our domain and range. For our domain, x is an element of any real number where x is not equal to n pi minus pi over 4. And for our range is from negative infinity to negative 3. And yun 1 to infinite.
Let's move to graphing second function. Y is equal to secant x. Secant is the reciprocal of cosine. Secant x is equal to 1 over cosine x. Secant is undefined whenever cosine x is equal to 0, which happens at x is equal to pi over 2, 3 pi over 2, and so on. A step-by-step process on graphing a second function. First is you have to graph the y cosine x slightly as a guide. Second, you have to mark the vertical asymptotes. This occurs at x is equal to plus minus pi over 2, plus minus 3 pi over 2, and so on. Third, you have to identify the key points. At cosine maximum, secant has a minimum at y is equal to 1. At cosine's minimum, secant has maximum at y is equal to negative 1. And lastly, you have to sketch the U-shaped branches at the peak and throughout the cosine.
And now let's have the example number 6 for secant. So y is equal to secant x minus pi over 2. So the reciprocal of secant is cosine. So it becomes cosine x minus pi over 2. And now let's get the amplitude. Since it is second, so I think it is 1. Our amplitude is 1. And for our period, period is equal to 2 pi over b. Since we don't have b, so 2 pi. And for our this phase shift, we have c over b. Our c is pi over 2. Since we don't have b, so 0. So 0. So it is equal to pi over 2. And now we have to get our distance each k point, which is the period and over 4. So our period is 2 pi. 2 pi over 4 is equal to pi over 2. Now let's do our table of values. So the purpose of table of values is it helps us to graph later, and in order for us to not get lost when we do the graphing. So since it is only a one period, so x and y, here t5. So first we have to write our phase shift. We start with our phase shift, which is the pi over 2. Now I'm pi over 2. So our pi over 2 is add to our distance, it becomes pi. Then pi plus pi over 2 is equal to 3 pi over 2. Then 3 pi over 2 plus pi over 2 is equal to 2 pi. Then 2 pi plus pi over 2 is equal to 5 pi over 2. And now let's move to our y. So I start with 1, 0, -1, 0, and 1. So now, since we have the table of values, and now we can do the graphing. We have to put all our x here from pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. And for our y is -1, -2, 1, and 2. Now, since we are ready for graphing, now let's do the plotting. So our pi over 2 is in 1, and our pi is 0, is with 0, and our 3 pi over 2 is in -1, and our 2 pi is with 0, as you can see in our table of values earlier, and our 5 pi over 2 is in 1. So now we can graph it with broken lines. We carefully do it, since it will be our first or our basis for doing the second graph. And now let's do the marking of asymptote, which can be created at pi since it lays in 0. And also for the second asymptote, it's in 2 pi since likewise in the pi it lies on t0, which is our origin. After doing this doing the asymptote, we can now finally graph the second, which is the U-shaped branches, and every peak and the lowest your graph. So we must do it as always closer to asymptote, but not enough to touch them. And carefully do it slowly but surely. And we're almost done with our graph. Now this is our graph for second x minus 2 pi. And now let's move to our domain and range, which is our last process. Our range is from -infinity to -1 union 1 to positive infinity. And for our domain is x element of real numbers where x is not equal to pi over 2 plus n pi. Now this is our final graph. So let's move to our next example, our last example for second. So y is equal to 2 second 3x minus 2 pi plus 4. The reciprocal of seconds is cosine, so it becomes 2 cosine 3x minus 2 pi plus 4. Now, you can feel free to pause the video if you want to solve for your own. So A is equal to 2. So our amplitude is 2. For our period, we have 2 pi over B. And 2 pi over B is equal, B is 3. So, have our phase shift. C over B. Our C is 2. And R 2 pi and our B is 3. We cannot reduce it. So for our distance, we have period over 4. Our period is 2 pi over 3 and over 4 is equal to pi over 6. So distance, phase shift, period, and amplitude. And now let's do the table of values. So as I always stated, by doing table of values, it is way easier for us to do the graphing later, and it helps us not to get lost, and it can be our guide. So since it is a 2-period graph, so we have 10, 5, carefully to the line. So first we have to write our phase shift, which is 2 pi over 3, and you have to add this 2 pi over 3 with pi over 6. It becomes 5 pi over 6. Then 5 pi over 6 plus pi over 6 is equal to pi. Then pi plus pi over 6 is equal to 7 pi over 6. Then 7 pi over 6 plus pi over 6 is equal to 4 pi over 3. Then 4 pi over 3 plus pi over 6 is equal to 3 pi over 2. Then 3 pi over 2 plus pi over 6 is equal to 5 pi over 3. Then 5 pi over 3 plus pi over 6 is equal to 11 pi over 6. Then 11 pi over 6 plus pi over 6 is equal to 2 pi. Then lastly, 2 pi plus pi over 6 is 13 pi over 6. Since we are done with our x, so let's move to y. Since it has page 4, so it becomes 6. 4, 2, 4, and 6. Then 4, 2, 6, 4, 6, and 4. Since we're done with our table of values, we can now move to our graphing. We have to write all the x here from 2 pi over 3 to and for our last is the 2 pi. So you have to 1, 2 for our y, 3, 4, 5, 6, 7. Since it has a plus 4, so we move upward. So from 0, we are here now in 4, or positive 4, our new origin. We carefully do the broken lines, illustrate it. And now let's do the cosine graph first, which is we have to plot first. So for our, we have to plot our 2 pi over 3 is in 6. Our 5 pi over 6 is in 4. And our pi is with our 2. As you can see in our table of values earlier, you have to follow it. So our 7 pi over 6 is with our 4. And our 4 pi over 3 is with our 6. Our 3 pi over 2 is paired with 4. And our 5 pi over 3 is paired with 2. And our 11 pi over 6 is paired with 4. And lastly, our 2 pi is paired with 6. So it's 6. And now all you have to do is to graph them with a broken line. So graph the cosines with broken lines. Slowly but surely, so we can do the perfect graph for our cosine that will help us to have a perfect graph for our secant later. So since we're done graphing our cosines, we now have to graph or mark our asymptote, which is who lies at our 4, our origin. So 5 pi over 6 lies at 4, so it becomes our asymptote, as well as our next asymptote, which is who lies at 4. Here the 7 pi over 6 as well. To carefully do the broken lines. These broken lines stands as our boundaries later when we do the graphing of secant or when we do the U-shaped branches. Our 3 pi over 2 as well lies in 4 is our third asymptote. And for our last asymptote, who lies at 4, is to it is our 11 pi over 6. So now we're done with marking our asymptote. We can proceed to finally do the U-shaped branches on every peak of our cosine graph. So carefully do the U-shaped branches. As I always stated, it must be closer to the asymptote but not enough to touch them to perfectly do it for you to have a perfect graph. So you have to do the U-shaped branch in every peak of your cosine graph. So what you do in the first one, you have to do it in the second one. So as I always stated, your U-shaped branches must always be closer to your asymptote, but not enough to touch them. So it is a 2-period graph. You can see we're almost done to our 2-period graph. So after doing this graph, we'll now proceed to writing our domain and range. And since we're done with our domain, we are done with our graphing, we can do the domain. So our range is from negative infinity and 3 union 5 to positive infinity. And for our domain is x, element of real number where x is not equal to pi over 6 plus n pi over 3. And that's it for our domain.
To sum it up, tangent and cotangent have a pi period and vertical asymptote at different points. Cosecant and secant have base on sine and cosine, and you have U-shaped branches around asymptote. By following these steps, you can graph each function accurately. Here are some final tips. First, always start with a base function, sine or cosine for secant and secant. Second, for tangent and cotangent, focus on asymptote and key points first. Third, use symmetries to your advantage when plotting points. That's it for today's lesson. If this helped, give it a thumbs up and then subscribe for more math tutorials. See you next time.